Okay, d orbitals, right? So we studied about what? We studied about non-axial ones, non-axial ones, non-axial d orbital. Now we'll study about the axial d orbital, the axial d orbital. What are the two axial d orbitals? We studied here how many? 3. So, and in d orbital, the d subshell, the magnetic quantum number is -2, 2 plus 2. Hence, we have 5 orbitals. So, we have already learned 3. The remaining is 2. The remaining is 2. What are these two? This is first, let me draw it. Okay, so this is d x square y square. Hence, this is x-axis and this is y-axis. And we can see that we don't have any probability, any density of electron in the z-axis, correct? We only have in the x and y-axis. Hence, we can say that it is directional. It is directional in nature. It is directional in nature. Now, the last one is and this is a ring, and this is a ring. This is z-axis, this is z-axis, this is x-axis, and this here is our y-axis. So what is there? Lobe at which axis? Tell me. Lobe at
Z-axis.
z-axis. Very true. Z-axis. And this ring at
X
the
and
xy
Y.
plane.
X-axis. Yeah.
No, not x-axis. The xy plane. Yes, the xy plane. It is a planar ring. Rings are plane. Let me just show that to you. Can you see this?
Yes, sir.
Yes. So this is the z-axis, and in between is that yellow thing, which is the xy plane, and it is the ring. You have the dz square like this. This is called dz square. This is called dz square, and both of them are what? Directional in nature. Electron density are only at some points. They are not at all points, like in the S subshell, So please copy this in your notebook. Then we will do some questions. We will check the knowledge of your quantum numbers. We will check the knowledge of your quantum numbers, the things that I have taught. Then what I will do? Then I will teach you electronic configuration. We will learn electronic configuration. Now, we will do questions. Okay? We will do questions. What question? Write the quantum number. Wait a second. We didn't do magnetic quantum number, right?
No, sir.
No,
Okay,
sir.
first. Okay, fine. Yes, what did we do last? The orbitals. Just look at f orbitals. F orbitals, you don't want to know the shapes because they are very complex. It is not in your syllabus, neither in the NEET and JEE mains syllabus. F orbitals, the only thing that you have to know is the azimuthal quantum number is equal to how much? Tell me. Azimuthal quantum number for F.
3.
Yes, very good. 3. So the magnetic quantum numbers would be
-3 to
-3,
3,
2,
including 3.
1, 0, +1, +2, and +3. Now, the third point, number of orbitals. What will be the number of orbitals? Number of orbitals is equal to
7.
Yes, 7. Say loudly. You can say loudly. No, not a problem. The last quantum number, the fourth quantum number is spin quantum number. Spin quantum number. How do we denote it? S or M with a S in the subscript. There are only two possible values. There are only two possible values two possible values for spin quantum number. Spin quantum number. What are those values? Plus
Plus
half or minus
minus
half. Plus half or minus half. Okay. Plus half is usually denoted for a clockwise rotation, and this minus half is usually denoted for anti-clockwise rotation. See, the electron is also revolving, and it is also rotating in its own axis. Right? So if it is rotating on clockwise direction, we say it's plus half, and if it is in anti-clockwise direction, we say it minus half. It is just for representation purpose. Plus and clockwise does not have any other relation. Okay. Now we can start with the questions. Write PQN, that is principal quantum number, azimuthal quantum number, and magnetic quantum, azimuthal quantum number and principal quantum number. That's it. And then you will tell me of the following. What is this? Tell me, what is this? 1s. What is the subshell that you can see here?
S.
S subshell. Now go to your notes and see what azimuthal quantum number corresponds to the S subshell. What azimuthal quantum number corresponds to S subshell? You have not written in the notes?
0, sir.
0. See. Now tell me for 2s.
Here also for S 0.
Yes, very good. Now, okay. Now tell me for this 2p. What will be the azimuthal quantum number?
1.
Very good. Now you will tell me what will be the azimuthal quantum number for D?
2.
Very good. And again, Rania, now and please unmute yourself and tell me what would be the azimuthal quantum number for S. Here it is. What would be the azimuthal quantum number for the S subshell? Very good. Very good. And what you have to do for principal quantum number? Nothing. You have to do nothing. Literally nothing. Here it is 1s. What does this mean? 1s means that the S subshell of which shell? Tell me. Abir? Tell me, the S subshell of which shell?
1.
Yes, easy. And if the number of shell is 1, what will be the principal quantum number?
1.
Yes, very good. Very good. Now, Ahmed, tell me, what would be here in 2s? Very good. See, very easy. Rania Rizwan, tell me. Rania Rizwan, yes, very good, very good. In chat, very good. And here it will be 6, and here it will be again 2. Let us take this question. If somebody will ask you, calculate the number of electron that the first shell can accommodate. So even the 10th class children can answer what? How many number of electrons in the first shell?
2.
2. But I will ask the class 10 student, how? What they will say? They will say, I don't know, sir. Teacher told me, science madam told me 2. So I said, okay. But now you are in 11th standard. You will tell me how, okay? You will just answer me a series of questions. Okay. Let me take one of you. Ahmed. No, let me take Ahmed. Okay, fine. Ahmed.
Yes, sir.
Yes. I will ask you a series of questions and you will only prove that how it is true. The first shell, what should I write the principal quantum number? Tell me.
Principal quantum number 1.
1. Very good. What would be the azimuthal quantum number?
0.
It will be 0.
0.
0. And what will be the magnetic quantum number?
It will be -1, 0,
Minus
and
1.
plus
Oh
1.
my god, how minus 1? How minus 1? Azimuthal quantum number is L. It is what?
Okay. L.
L. Magnetic quantum number is minus L to plus L. Ask
So it will be
ask whom?
0.
Ask Mariam. She has done PhD. She has done PhD. Minus L to?
L.
Yes, very good. Plus L, right? Now this also including 0.
0.
So
it
here
will
we
be
don't have
0.
any negative numbers or any numbers. So what we will write? Magnetic quantum number is equal to
0.
0. Now I have written in. You must have written in your notes that number of values of magnetic quantum number is equal to number of values of magnetic quantum number is equal to number of orbitals, number of. So if I will ask you number of orbitals, what will you say? How many values of MQN? Only we have one value, right?
Yes.
Number of orbitals is equal to
1.
one orbital. And we have seen that in spin quantum number that the electron can either have plus half spin, either clockwise or anti-clockwise. So if there is an orbital, either it can move this like this or like this. So this is denoted as what? Plus half, and this is denoted as what? Minus half. Okay. So what can you see here? We have only one orbital, and each orbital can contain how many electrons? Only 2 electrons. Each orbital can contain how many electrons?
2 electrons.
2 electrons. So we see that the first shell has only one orbital, and hence it can occupy, and hence it can accommodate on only how many electrons? Only
2 electrons.
2 electrons. So now you will tell the 10th standard students that there is a reason. There is a reason for the first shell to accommodate only how many electrons? 2 electrons. How many electrons?
2 electrons.
Yes, very good, very good. And you will write the answer here. The first shell can accommodate 2 electrons. What is the question? Calculate the number of electrons that the second shell can accommodate. Okay, the second shell can accommodate. Now listen carefully. I will not ask anyone. I will show you how the second shell is equal to second. Therefore, the PQN, principal quantum number, this will be equal to how much? 2. Then I will write AQN. AQN will be equal to how much? 0. That is, let me write the formula first. Okay, be equal to 0 to n minus 1. That is 0 to 1. That means we have 2 azimuthal quantum number. So for each azimuthal quantum number, what we will have? We will have the magnetic quantum numbers for each of these azimuthal quantum numbers. What are these? These are L's, right? This is L. And for this also, we will have the magnetic quantum number. What will this equal to? Minus L to plus L, including 0. Again here, minus L to plus L to plus L, including 0. So if we see for 0, this will be equal to 0. If we see for 1, this will be equal to minus 1, comma 0, comma plus 1. The total number of orbitals will be equal to 1. The number of values for MQN, it is equal to how much? Number of orbitals is equal to how much? 4. Therefore, number of electrons will be equal to how much? 4 into 2. Each orbital can accommodate how many electrons? 2 electrons. That's why 8. See, what is the question here? Calculate the number of electron that first shell can accommodate. What is the question here?
Third shell.
Yes, very good. See, patterns. Now calculate the number of electrons that the third shell can accommodate. Now, I'm writing this and you will let me know if you have any doubt. First, what did I write? The shell. What is the shell? It is third shell. It is third shell. So the PQN, principal quantum number, denoted by N, will be equal to how much? 3. So the AQN, denoted by what? L, lowercase l, will be equal to how much? 0 to n minus 1. What is n? 0 to n minus 1. 0 to n minus 1. What is 1? What is n here? It is 3. So 0 to 2 minus 3. What we will get? We will get these three numbers: 0, 1, and 2. So 0 will have its own MQN, 1 will have its own MQN, and what? 2 will have its own MQN. 2 will have its own MQN. What will be the MQN for 0? It will be 0. Right. Let me just write this like this first. It is MQN. It is minus L to plus L. What do we have here? We have L. Yes, Mariam Bai, I know that you have done PhD. Oh my God. Wrong answer.
So it's 2 by 1.
PhD has given us wrong answer. Wrong answer. That's not correct. Try again. Write down in your notes. Try again. Yes. Tell me. Somebody has the answer.
It will be 3 minus 1, right? Here. You wrote 2 minus 3.
Oh, yes. I'm really sorry. Yes, correct. Thank you for correcting me. This will be 3 minus 1. Thank you. So this will be 0. This will be minus 1. 0, comma, plus 1. This will be minus 2, comma, minus 1, comma, 0, comma, plus 1, comma, plus 2. Okay. Now add these. This is how much? 1. You have to add the values, right? 1, 2, 3, 4, 5, 6, 7, 8. How many? Tell me. 9, right? So 5 plus 3 plus 1. 5 plus 3 plus 1. This is equal to how much? 9 orbitals. How 9 orbitals? The number of values of magnetic quantum number is equal to the number of orbitals, is equal to the number of orbitals. So number of electrons will be how much? 9 into
2.
Very good. So this will be how much? 18 electrons. Calculate the number of electron that you have done the third, that the fourth shell can accommodate. Yes. Start 1 minute. You have 1 minute. Everyone got 32?
Yes, sir. Everyone
got 32. Okay, very good. Right. Everyone got 32. So I don't need to explain anything else. Now see, somebody asked me, is the formula for magnetic quantum number 2L plus 1? I said, no, that is not a formula. That is an observation. I will write the N, then I will write here the L. Okay. Then I will write here the M. Okay. Then I will write here the S. Then here S is only how much? Number of electrons I can write. Number of electrons in shell. Number of electrons in shell. First of all, let me make some rows and columns. Then we will start writing down. Then you all will be deriving those tricks that some people who masquerade as teachers and call it formula. How can they call it formula? That is not a formula. That is an observation. That is an observation. That is pure arithmetics. That is pure arithmetics. That is arrangement of different things to make it. See, what is arithmetic? You take, you cannot count this very easily. You cannot count this very easily. What do? You make things simple. You arrange things like this. Now, if I ask anyone how much is this, they will say 12 in one instance. But if I write one like this, they cannot say it. So what you have to do? You have to arrange things in some way that you can recognize easily. Now, for the n is equal to 1, it is very simple. It is very simple. Abir, please unmute your mic. Are you there? Yes. Now tell me, what will be the value of L?
0.
0. What will be the value of M?
0 to minus L to plus L.
And that will be equal to how much?
1.
No, it will be 0, right? The values you will get will be 1, only one value. You will get only one value. But what value will you get? It will be 0.
0.
The value will be 0. The number of values will be 1.
1. Okay.
We'll get one value, right? So this will be here. We can write number of electrons. So M will be 0 and only one value. Hence, what we will write about what we will write. Number of orbitals is equal to 1. Number of electrons will be, Abir, tell me.
2.
Very good. 2. Now, if n is equal to 2, L will be equal to how much? 0 and 1. Correct? 0 to n minus 1. 0 to
Yes.
n minus 1. So, sorry, wait a second. This will be from here. Don't write anything now. Don't write anything now. Don't write anything now. Okay. Just look here. I will give you ample amount of time to writing things. So here again, this will be 0. Number of orbitals for 0 will be 1. Number of electrons will be 2. Okay. Now, for L is equal to 1, the M will be equal to minus 1, comma 0, comma plus 1. Number of orbital will be, count the number of values, 1 value, second value, third value. So it will be 3. Number of electrons will be 6. Okay. So add these two. Add these two. What you will get? 8.
8.
What you will get? 8. Okay. Now let me write for the third shell. For the third shell, the values for L will be. Rania Rizwan, tell me. Write in the chat. Rania Rizwan, what will be the? Very good. Very good. I'm impressed. 0, 1, 2. Any doubts? Anyone else? No doubt, right? No doubt. Okay. For 0, the value of M will be 0. Number of orbitals will be 1. Number of electrons will be 2. For 1, it will be minus 1, comma 0, comma plus 1. And this will be number of orbit will be 3. The electrons will be 6. This will be minus 2, comma minus 1, comma 0, comma plus 1, comma plus 2. Number of orbitals will be 5. The number of electrons will be 10. This will be equal to how much? 18. Before noting this down, let us start with some observation. Let us start with some observation. The first observation that I can see here is that if I say total number of orbital in a shell, total number of observations. Here I am writing observations. Total number of orbitals in a shell is equal to for the first shell, the number of orbitals is equal to how much?
4.
No, for the first shell. For the first shell, number of orbital is only 1. How much?
Yes.
Only
1.
1, right? For the second shell, the number of orbital is equal to how much?
4.
For the third shell, the number of orbital is equal to how much?
9.
Now tell me, for the fourth shell, number of orbital is equal to how much?
16.
Very
16.
good. For fifth shell, the number of orbitals is equal to how much?
25.
Very good. So what will be the formula? The formula. People say
N
formula.
square.
It is not formula. It is observation. It will be n square. It will
N
be
square.
very good. Now the next thing. Total number of electrons in a shell. In a shell is equal to how much? Tell me.
N square.
Oh
N
my
square into
God.
2.
No. Yes. N square into 2. Correct. That we will write 2n square. What we will write? 2n
2n
square.
2n square.
Now, for the magnetic quantum numbers, that is m, what we can see here is, if we multiply, see these are the two numbers, plus 1 and minus 1, right? If we, these are two numbers and this 0 is 1 extra. This is 1 into 2, 1 into 2 plus 1. See. So what will be the formula? Number of orbitals is equal to 2l plus 1. How did we reach at this formula? See, arrangement. What? Arrangement. How do you arrange? If you see this, if you see the second asymmetrical quantum number 2, which correspond to the D subshell, if you write it like this, minus 2, minus 1, minus 2, minus 1, then you write plus 1 and plus 2. This is equal to how much? This is equal to 4, which is what? It is 2 into the value of L. 2 into the value of L. What was the value of L? It was 2. And you also have what? 0. So the another value will be plus 1. Correct? And then you get how many? 5. You get how many? 5. So by that observation, what you can write, number of orbitals is equal to 12 plus 1. Number of orbitals is equal to 12 plus 1. Calculate the number of electrons that the following set of quantum numbers can accommodate. Now, let us look at the B example. I'm doing the B example. Okay, you will do the rest. You will also observe what kind of sequence I am following while I am solving this type of question. Okay, this is much easier than what we have done earlier. First of all, I will write the givens. What are given? Given is, first of all, the n, which is equal to 1. Then I will check, do I have L? I will say yes. L is equal to 0. Then I will say, okay, fine, L is equal to 0. And what will be the m? M will also be equal to 0. So then I will write number of orbitals that is equal to the number of values in m. The number of values in m is 1. So number of electron is equal to 2. Now some other type of question, I will also do this. N is equal to 2, comma L is equal to, let us say 1. Then we will also give you m is equal to 0. Okay, so what you will do here, m is equal to 0. You will see given. What are these given? Given is n is equal to 1, L is equal to 1, m is equal to 0. M is equal to 0. So now they have also given you the M. You don't have the choice. You cannot write the magnetic quantum number for L is equal to -1, 0, and 1. Correct? They have given you 0. So you just have to concentrate and focus on the 0. Okay, this is a set of quantum numbers. So what will be the number of orbitals? Number of orbitals is equal to the number of values of M, that is 1. Number of values of M, that is 1. So number of electrons is equal to 2. What you have to do in each of these type of questions, that you have to write the givens, then start calculating the number of electrons. You cannot calculate the number of electrons directly from L. You have to go to M. Then you have to go to number of orbitals. Then you have to multiply the number of orbitals by 2, and you will get the number of electrons. If you have been given only n is equal to what? N is equal to, for example, let us say 2. Then you will calculate all the possible values for L. Then you will calculate all the possible values of M. Then you can say, okay, number of orbitals is equal to number of values of M. Okay. Now let us start. I've done the A for B. B, n is equal to 3, comma, L is equal to 2. Okay. And also remember, this is the sequence that we are going to follow. If we have been given PQN, then we will see what? If we have been given AQN. If we are given AQN, then we will see if we are given MQN. If we are not given AQN or MQN, we will derive it from the previous one, the previous quantum number. And at last, spin quantum number. Okay. We will check all of these. If the PQN given, then we will calculate AQN. If AQN is not given, then we will calculate AQN from PQN. And if AQN is given, the PQN has no value. We'll calculate from azimuthal quantum number. For example, in B, Rania is 1. Do we have any value? Do we have any significance? Is this of any significance? Tell me. Rania is 1. N is equal to 3. This is PQN. This is AQN, azimuthal quantum number. So when azimuthal quantum number is given, does the principal quantum number has any significance? Others can also answer. Yes, very good, Abhi. The principal quantum number has no significance. We will calculate the number of electrons only from this L value, that is azimuthal quantum number. And to move forward, what we have to write? We have to calculate the magnetic quantum number. And so we will write M is equal to -2. It's 1, 0 plus 1, and plus 2. And number of orbitals is equal to 5. So number of electrons is equal to what? 2 into 5, that is equal to 10. For the C question, we don't have any significance. This data has no significance. Hence, we will start calculating from L. L is equal to 1. So M will be equal to -1, 0, plus 1. Orbitals is equal to how many orbitals? Orbital is equal to 3. Electron is equal to how much? 3 into 2, that is equal to 6. Now we will move to the D question. We will see principal quantum number given. Okay, azimuthal quantum number given, then principal quantum number has no significance. And we will move forward. Magnetic quantum number given. Okay, given. Then the azimuthal quantum number has no value. The last value, the last quantum number in this series which has been given, we'll check only that. D. For M is equal to 0, number of orbitals is equal to the value of M, number of values of M. Now Rania is 1. Tell me, the number of values of M is equal to how much? The number of values of M. How many M are there in D? In this question, Rania is 1. Please tell me. Write in chat. Not 0. There is one value. Whose value is 0. Do you understand this subtle difference? The magnitude of the value is 0, but the number of values is 1. What is the number of values of this? Count it, count it. There are three values. There are three values, 1, 1, and 1. Tell me once again. Rania is 1. Once again. Tell me number of values. Tell me number of values in this bolded part. Very good. You are understanding. Now tell me m is equal to 0 and the number of values is equal to 1. Hence orbitals. Orbitals is equal to 1. Electron is equal to 1 into 2. That will be equal to 2. Now moving ahead. For the E question, n is equal to 2. N is equal to 2. Then what we will do? What we will do? We will take this observation. What we will do? We will take this observation and this observation. Okay. So what happens? Number of electrons. Direct observation. What is observation? 2n square. 2 into 2 square is equal to 2 into 4 is equal to 8 electrons. 8 electrons in second shell. This was the question number E. We have been given principal quantum number. Be fast. Say yes, sir. Type in chat. Yes, sir. Then what we will check? L. Okay. If the azimuthal quantum number is given, do the principal quantum number has any significance? No. Very good. Now we will check the next one. We have been given the magnetic quantum number. If the magnetic quantum number is given, do the azimuthal quantum number has any significance? No. Very good. If magnetic quantum number is given, we will move forward. The spin quantum number has been also given, so the magnetic quantum number also hold no significance. No significance. Hence, what we have, S is equal to plus half. Plus half. What does that mean? An electron. An electron in clockwise direction. That is only an electron. An electron. An is indefinite article, but it signifies one electron. Only one electron. Only one electron. Now the next type of questions that we get is predict if the following set of quantum numbers are possible. Before that, in these type of question, as soon as you see, are the following set of quantum numbers possible or orbitals? You can get quantum numbers or orbitals. As soon as you see this type of question, what will you do? You will do this. You will make a line in the side of your notebook and write each and everything. What is the value of n? Abir, tell me. What are the possible values of n? Very good. 1, 2, 3, and so on. These are the possible values of n. N cannot be 0. If somebody says n is equal to -1, he's wrong. He is wrong. What will be the possible values for L? It will be 0 to, Ahmed, tell me how much?
n minus 1.
Very good. N minus 1. And for M, it will be equal to minus L2 plus L. For S, the values are plus half or minus half. Okay. As soon as you get this question, make a line here and write all these 4 statements. Now, for A, what is given? 2D. What is given? 2D. What you will write? You will write in this sequence. Whatever information is given, you will write each information in this sequence and you will check in each step. You will check in each step. If it is written 2D, n is equal to how much, Abir?
2.
Very good. 2. Then you will check subshell is D. Subshell is D. So L is equal to how much? This is equal to 2. Now what you will do, you will check if this matches the criteria to this. Okay, if this matches the criteria or the formula of L. What you see here is that it is not possible. That it is not possible. If n is equal to 2, L should be n minus 0, 0 to n minus 1, 0 to n minus 1. That is the another point that you can write it. L is always less than n, is always less than n. So what you will write here? 2D is not possible. 2D is not possible. Okay. Now for B, you will check 1. Abir, now you will tell me.
N is equal
N is equal to
1.
n is equal to 1. L is equal to
1.
1. So is this possible? In each step, n is equal to 1 is possible. Is L is equal to 1 possible if n is equal to 1?
No, sir.
Yes. So this will be also not possible. For C, Ahmed, please unmute your mic and tell me n is equal to 2. Is this possible? N is equal to 2 is possible?
No, sir.
N is equal to 2 is not possible.
It is possible.
N
Like
is
L is equal to 0 is not possible
Oh
in
my-
this case.
Oh my God. Oh my God. Why? Why? Tell me why. This is the criteria. This is the criteria.
Because because L should be n minus 1, 0 to n minus 1, and it is n minus 2 over here.
This is 0. What is this? This is 0. This is
0.
0. This is, so it is possible, right? Only less than. Okay. It should not be minus, but it should be only till
Okay.
0. So this
So
is
it is
possible.
possible.
Then
Yes,
we
sir.
will go for m is equal to how much? Minus 1. Is this possible if L is equal to 0? If L is equal to 0, m is equal to how much? Minus L2 plus L. But there is no whole number here. So m should be only 0. But we have we have been given? M is equal to minus 1. So this is
Not possible.
not possible. Very good. Very good. Now for 3D. 3D, n is equal to 3, comma, and L is equal to 2. So we can see that L is less than 3 and it is not a negative number, and this is possible. And this is possible. Oh, wait a second. B, C, D. Okay, then M. M is equal to 0. If L is equal to 2, then M will lie between minus 2, then minus 1, 0. So if this is 0 is there, so M is 0. This is correct. For 3D, n is equal to 2, comma, L is equal to 2. We see that n is equal to 3. L is less than n, and this is possible. For 1P, n is equal to 1, comma, L is also equal to 1. But the criteria is that L should be less than n. But here we see that n is equal to L, and it's not. So 2D is, this is not possible. B is also not possible. C is also not possible. D is possible. E is possible. F is not possible. Now we will move to this slide. This slide here is very important. We are starting electronic configuration. We are starting electronic configuration. What is electronic configuration? This, what we do here is filling of electrons in orbitals. Okay. And before going to the discussion, what we will be having discussion about are the, I call this as first principles of chemistry. First principles of chemistry. I mean, this is the thinking process that you have to develop if you are dealing with chemistry. And these are the principles by which the generalization have been determined. Okay, the generalization and the generalization are derived from these first principles. Okay, now what are the first principles? Why I am telling you this here? Because we have to fill electrons. What we have to do, Abir?
Fill electrons.
Fill electrons. That means we have to place the electrons somewhere in the orbital. And if you want to place it somewhere, we have to place it such that it should not leave the orbital. Correct? It should not
Yes, sir.
leave the orbital. So what we will do, we will generalize how each and every object in this universe want to stays as. You have your pen. Hold it above. Hold it like this. And without applying any force, just leave it. Hold it like this, the pen, and leave it. And tell me what happens.
The
It
pen
falls
drop.
down.
It falls down. What happened was it had the potential energy when it was in the above state. Okay, and as soon as you just remove the grip, it falls down. Now as soon as your pen is below here, it does not have potential energy. That means that the pen did not want to have potential energy. The pen does not want potential energy. Each and every state, each and every system in this universe want to attain minimum energy. Want to attain minimum energy. This is the first principle. This is the first principle. Each and every system here, the pen is system. Here the pen is system. Each and every system wants to attain minimum energy. Minimum energy. Now the only thing that we have to do is to minimize the energy. We have to put electrons in such a manner that their energy is minimum. How do we get that? So for minimizing the energy, we have these following things. I will write this arrow here is for increase. Okay, what happens in chemistry? A changes to B. These type of things occur, and what we have to look, what is the energy of B system and what is the energy of A system. Okay, and if this process has led us to increase the energy, if there is increase in energy, what we have seen that it becomes unstable. Increase in energy, it becomes unstable. And what happens? This process is endothermic. If you increase the energy, that means you are giving the energy. If you are giving somebody energy, and any system in the universe don't want energy, okay, it wants minimum energy, that means you are making it unstable. So if there is increase in energy, the system is unstable and the process is endothermic. Similarly, if there is decrease in energy, the system becomes stable and the process is exothermic. Now there are other things which leads to increase in energy or decrease in energy or stability or instability. The first thing is increase in attraction. So whenever attraction increases, for us we have these things, positive charge and negative charge. If the attraction between them increases, it becomes stable. The system becomes stable, and if it becomes stable, it will release energy. It is exothermic. Now tell me, Ahmed, tell me what happens if we increase repulsion?
It becomes unstable.
Yes, right? It becomes unstable. And what will be this? This will be endothermic, right?
Yes, sir.
The next thing is an important thing. It is increase in Q density. Increase in Q density. Charge density. What is Q? Q is charge. If we increase the charge, for example, if the charge is pointed only towards this point and it is and the same amount of charge, here also we have Q charge and this also has Q charge, but the area, the space, it is dispersed. The space is dispersed, so the charge is dispersed. So what happens? It gives stability. Sorry, wait. If the charge density is increased, it gives instability. If the area and space is increased, it gives stability. The charge density increases, that means this becomes this. Hence, we get unstable. Hence, we get unstable. And the process will be endothermic. Now, last, Mariam, tell me.
Yes, sir.
What will happen if we increase the symmetry? In nature, everywhere, what do we see? Symmetry. Even if we have a leaf, it is symmetrical, correct?
Yes.
So if we increase the symmetry, we bring stability. System become stable and the process become exothermic. The process become exothermic. But this is not a part of your atomic structure. But I will use these first principles in the periodic properties. And we will derive each and every properties from these first principles. These first principles, see, are in books. These first principles are in books. I did not get it from anywhere else. Okay, these are not my own. These are in books, in chemistry books, but they are scattered everywhere. They're scattered everywhere. Okay, so these are my observation taken from books only. Correct. Now, if you want to fill electrons, then what do you think? Electron will want to go where? In the lowest possible energy state. The lowest possible energy state. And that is the Aufbau principle. That is the Aufbau principle. Okay. Aufbau principle. See, what is this? This is also a principle. And what I have written here, this is the first principles of chemistry. These type of principles are scattered over different type of organic book, different type of chemistry book, either the physical chemistry book, inorganic chemistry book, organic chemistry book, something that I'm currently studying upon and researching upon, that is computational chemistry. That is computational chemistry. Okay, so these things are scattered over everywhere. These first principle. So what is Aufbau principle? It states that in ground state of an atom, in ground state of an atom, electron fill the atomic orbitals. Don't write now, please listen. The atomic orbitals of lowest available energy level, comma, before filling the higher energy levels. So what does this mean? The ground state. Mariam, tell me.
Yes, sir.
If you drop your pen, it will reach the ground. And at that point, no, I mean, if you drop it from your floor that you live onto the road, in the sea, if you have sea on the sea level, that means the ground state is something where it does not have any extra energy. Correct? As soon as you hold your pen and lift it up, you have given it what? Potential energy. Correct? What is ground state? when no any other energy is given to a system. Okay, that is ground state. So in the ground state of atom, when the atom is untouched, you have not given any energy, you have not even heated it. Okay, then in the ground state of an atom, electron will fill the atomic orbitals. We have seen atomic orbitals. What are atomic orbitals? 1s, 2s, 3p, 4p, 2p, right? These are atomic orbitals of lowest available energy. That means that our aim next class, it will be about, what will be it about? How to determine the energy of different orbitals.